Assalamu alaikum everyone and welcome to Physiochem.acadmey. Basically, I am planning to make a series of lecture on thermoanalytical method in which we will be covering different thermoanalytical technique including thermogravimetric analysis, differential scanning calorimetry, thermomechanical analysis and so far DTA. Before going into the detail of these thermoanalytical technique, let's have a look at the definition of thermoanalytical method. Basically, in analytical chemistry, there are two types of the method which are being used for the analysis of a compound. The very first one is spectroscopic method, in which we measure the interaction of light with the sample, or we can say the interaction of light with the substance, or interaction of light with the matter, and we make the analysis. And the second one is thermoanalytical method, in which we measure the thermal behavior, or we can say the thermal property of a compound. So the very basic definition of thermoanalytical method is a group of analytical method in which changes in the physical or chemical property of a substance is measured as a function of temperature, or we can say as a function of time under the controlled temperature program. Now, by controlled temperature program, we mean having a constant heating rate, Now, if we move down, if you think that why all these four methods which are being mentioned here, why all these four methods are being placed in one group? So there is only one reason. Why all these four methods are being placed in one group? There is only one reason, that all these measure the thermal properties. You can say thermal properties, or we can say thermal behavior. So because of this reason, all these four methods are being placed in one group and they are named as thermoanalytical method. No, there is a wide area where the application of thermoanalytical technique are being used. I have mentioned some of the area, but we will look at the detail of the detail about the application with the every thermoanalytical method, because this is the most important part of the thermoanalytical method, that you need to know about the application of thermoanalytical method, because these applications are being used in the different area and the practicals. Thermogravimetric analysis. It's clear from the name that thermogravimetric analysis is a combination of three words. The first one being therm mean heat. The second one gravy, which means mass, or we can say weight. And the third one metry, which means measurement. No, in thermogravimetric analysis, we will basically measure the relationship between the heat and mass. And this relationship between the heat and mass, as we know from our basics chemistry, that when we provide a heat to any compound or any mass, there will be changes in the mass of that compound. And these changes will totally depend upon the amount of heat provided or the level of the heat provided. Like if we provide low heat to the sample, or we can say mass, then there may be physical changes in the form of evaporation or dryness. And if we provide high heat to the compound, there may be phase change, there may be chemical changes. So we will observe different changes at the different level of heat we provide. And all these relationship between the heat and mass can be studied through the thermogravimetric analysis. And we will look into the detail into these changes in the compositional analysis, which will be covered later in this video. I have write down a very simple definition of thermogravimetric analysis, that it is a thermoanalytical method in which change in the weight, or we can say change in the mass of a substance, is measured as a function of temperature, under the controlled temperature program. Now, if we move down into the types of the thermogravimetric analysis, so there are two basic type of thermogravimetric analysis. The very first one being isothermal TGA, and the second one dynamic TGA. Now, first look at the isothermal TGA. The word isothermal, as you all know, here the temperature will be constant. So temperature here will be constant. Sorry, let me write it properly. Temperature will be constant and time will passes. Isothermal TGA involve maintaining a constant temperature while measuring weight changes over time. Over the time. Now, using each type of the TGA, this will depend upon the application we are looking for. For example, if we are looking for the thermal stability, like if I write it down, if we are looking for the thermal stability at some particular temperature, we will perform isothermal TGA. The second one, if we are monitoring a reaction at some particular temperature, again this is temperature. So if we are studying thermal stability of any compound at some particular temperature, or we are looking for or monitoring a reaction at some particular temperature, then we will go for the isothermal TGA. In the same way, in the dynamic TGA, dynamic TGA involve heating or cooling a substance in an environment whose temperature is changed in a linear manner. So in this TGA, the temperature will not be constant. We will increase the temperature in a linear way, and this TGA is basically used to find out the kinetic or to study the kinetic triplet, or we can also say it degradation kinetics. We will make a separate video on the degradation kinetic because It is the most important part of the thermogravimetric analysis, and from this degradation kinetic, we will be able to find out the activation energy, frequency factor, and reaction mechanism. So, this is going to be in very detail, and we will cover it in a separate video. Now, looking into the application of the thermogravimetric analysis, the very first one being the thermal stability is clear. Already I have mentioned twice or thrice the term mean heat and stability mean to bear something or to show resistance to something. So thermal stability, in thermal stability, we check how much a substance bear at temperature. So let me take the pen. Here we check how much a substance can bear temperature. Like how much is its stability, how much a substance can bear the temperature. For example, if we are talking about the metal, there is a certain limit for every compound that it will for every compound or for every metal that it will bear up to that temperature, and after that it will go into degradation. So we can check the thermal stability of any compound by using the thermogravimetric analysis. The very second application is moisture content can also be checked through thermogravimetric analysis. As I mentioned already, that many of the compound contain moisture, or we can say water, and these moisture or water, when we heat a substance, the moisture or the water will be removed, and this will be a physical change. So this moisture content or water can also be checked out through the use of the thermogravimetric analysis. The third application is a level of volatility, and level of volatility is actually to study that either the compound which are under observation is volatile or not, and this application is used to decide the bottle for different product. Also, this is used to select or choose expiry date and different company of different product. So level of volatility can be used to decide the different bottle for the different product, and also this application can be used to select the expiry date, which we came across a different thing that there is a special expiry date over each and every product. So this can be decided through the thermogravimetric analysis after checking the volatility of the compound. Now the fourth one is carbonization temperature. Basically, carbonization is let me take the pen. Carbonization is a process in which substance is heated in the absence of air, or we can say without air or oxygen, to leave a solid porous carbon. Solid porous carbon. Carbonization temperature is basically that temperature before which all of the constituent of a compound will be burned out except the carbon. Only carbon will be left out, and the remaining all the things will be burned out. So at that point, the temperature will be called the carbonization temperature. And we find out the carbonization temperature because many time in our experiment we need only carbon, and for that carbon to gain it or to extract it from the different compound, we need the carbonization temperature so that we can burn out all the other constituent and we are only left with the carbon. So carbonization temperature can also be decided by the use of the thermogravimetric analysis. Filler content. Uh, Filler content is basically polymer during composite, or we can say during composite formation, metal are introduced into polymer. So metal metal are metal are introduced into polymer during composite formation in order to enhance, or we can say improve the properties. So in order to improve or enhance the property of the polymer, we introduce a metal into it. And this metal can be the weight of this metal can be found out by use of the thermogravimetric analysis. As we know, polymer are organic in nature. Uh, as we all know that polymer are organic and easily burn out. If you provide small heat, this will be burned out and we will be left only with the metal. So how much of the metal is present in a particular composite, this can be found out by the thermogravimetric analysis. Now, the sixth one being degradation kinetics is, I already mentioned that we will make a separate video on the degradation kinetics, but here just look at the degradation kinetic. This is also called kinetic triplet, kinetic triplet, and here we will study in kinetic triplet activation energy, frequency factor, and reaction mechanism. We will find out these three in a separate video lecture. Now, let's move to the composition analysis, which is the most important part of this lecture. Composition analysis. For the compositional analysis, to study the composition analysis of any compound, let's say we here select one example and we will study that at which stage of the thermogram which of the element has been lost from the compound, from our selected compound. So let we take the example of calcium oxalate. Calcium oxalate monohydrate. The chemical formula is calcium oxalate monohydrate. This is the chemical formula for calcium oxalate monohydrate. Now we are trying to make a thermogram for this. Let we take the temperature at x-axis and we take the concentration at y-axis. Now let the temperature range from 0 to 800 degrees centigrade. And now here our concentration at this stage is 100%. And after we increase the temperature, the concentration will decrease. There will be changes in the mass of the substance. So let's say at this stage, the concentration become 87.7%. as we increase the temperature further, let's say at this stage the concentration becomes 68.53%. This is 68. Let's say at this area the concentration becomes 38% as we increase the temperature. Now as we increase the temperature, as we already says that there will be changes in this will be straight. I'm trying to make it straight. This will be straight line. So as we increase the temperature, for some time the graph will be straight line, but after some time we will observe that there is a curve in the graph. And when we increase the temperature, as the temperature increases linearly, this will become straightforward. And after some time we will observe another curve in the graph like this. And as we increase the temperature, the graph will become again straight, and at certain temperature this graph will observe another curve, and after that the graph will become straight line. Now what does it mean, and how would you come to know that at which stage which of the element has been lost from the compound calcium oxalate monohydrate at different temperature? Now let's say here the temperature is 45 degrees centigrade. We can say, and here the temperature is, let's say 100 or 200 degrees centigrade. We are taking this, we have not calculated it properly, but we take it just to understanding this curve, for understanding this thermogram. No, at the very first stage, let me make the difference between the final and the initial. We will calculate for every curve, we will calculate a different value, and here we will find out that which of the element has been lost from this at this 40 degrees centigrade, at this 150 degrees centigrade, here let's say 300 degrees centigrade, and after that what is the residue. So all these we will calculate it now. The very first step is to find out the difference between the higher and lower value. So our higher value of concentration is 100, and here for this curve lower value is 87.7%. so here we will find out that the difference is 12.3%, and this loss has been occurred at this stage. Now for this step the higher value is 87.7%, and our lower value is 68.53%, and here we will observe that the loss that occurs is 19.17%. Similarly at this stage our higher value is 68% minus 38. Sorry, this is 68.53 minus 38%, and here we will find out that the loss is 30.53%. No, as we have calculated this loss, let me make some space so that we can write it. As we have now calculated this in percentage, we need to convert it into number. So to convert it into number, we will divide each of the obtained value of the percentage by 100. For example, at first stage we obtained 12.3, and this is in percentage. Here we will divide it by 100, and we will came to know that it is 1.23. Similarly, for the second step, we obtained a value of 19.17. If I am not wrong, yeah, percent, and this is equal to 100, and we will find out it is 1917. And for the third one, we obtained value of 30.53% divided by 100, and we will come to know that it is 0.3053. Now, in order to find out the molecular weight of the compound that of the element, or we can say the substance that has been lost at each curve, we need to know about the molecular weight of our compound that that is under investigation. So the molecular weight of the calcium oxalate monohydrate is 146. Now we will multiply each of these number with the 146, and we will find out the molecular weight of the substance that has been lost at different stages at different temperature. Now 146 multiplied by 123, and we will find out it is 17.9. So this is approximately equal to the molecular weight of water. Similarly, we will again multiply 146 with the 1.917, and this is approximately equal to if we calculate it, this will become 27.9, and this is approximately equal to carbon monoxide. Similarly, again we will multiply this with the 0.3053, and this will be equal to 44, which is the molecular weight of carbon dioxide. Now, to calculate the molecular weight of the residue that has been left at the end, we will again at the last stage we have for the residue. Let me take the pen. At the last stage for the residue, we will divide 38% divided by 100. We will find out that it is 0.38, and now we will multiply this 0.38 with the 146, and we will find out that it is 55.48, which is the molecular weight of calcium oxide. So now we have calculated for each step that which of the element has been lost at which stage and at which temperature. So here we have make a rough thermogram for this for the analysis, for the composition analysis of the calcium carbonate. So we can say that at this stage water has been lost here, at this stage carbon monoxide has been lost, and at this stage carbon dioxide has been lost, and here we are left with the calcium oxide. So through this way we can make the composition analysis of the each and every compound, and this will be properly you can study this kind of data properly from your textbook. So for now we have studied different application of thermogravimetric analysis. In the next video we will cover some other portion of thermogravimetric analysis. So take care, and thank you for watching this video.